Good morning, Kate.
And it's good to see you. Haven't seen you in a while.
Yep.
Hi, Kate and Anand. Anand, as I said, you can make me a co-host because I know you'll need to step out at some point.
Yep. Thank you, Dana.
Kate, I'll introduce people at the top of the hour if you'd like. Or Anand, you can.
You can go ahead, Dan.
Okay.
Yeah, I think we have quite a bit of people already in the call, so maybe we should get, I guess, yeah, just rolling into the top of the hour.
Should I get started? One moment.
Yeah, let me, Kate, I'll do a top of the hour introduction for everyone.
Oh, okay. I'll give them 1 minute.
Yeah, do you want to put on your first slide?
Sure. I'm mostly gonna have a demo, so a pretty short slide deck.
Okay,
But here's the start.
excellent. Hi, everyone. My name is Diana Sinton. I am a senior research fellow with UCGIS, the University Consortium for Geographic Information Science. And I work with iGuide, which is the Institute for Geospatial Understanding through an Integrative Discovery Environment, funded by the National Science Foundation and hosted at the University of Illinois. And we're very excited to welcome you today to today's virtual consulting office. VCOs are our technically oriented online sessions that highlight some of the types of activities that can be done with iGuide and that our iGuide platform supports. Today, we are really excited to welcome one of our own, Dr. Kate Vavermusser, who is currently a postdoc at the University of Minnesota. And Kate's going to be talking about how she's been using the platform to support a series of spatial notebooks that she's created and produced and now has hosted on the platform that use R. So this session is being recorded. It will be posted on the iGuide website later after it's been processed. And we're using the Zoom meeting format rather than a Zoom webinar format. Please take responsibility for your own microphones to keep them muted. The best way to pose questions for Kate is to put the questions in a chat. And then I think it's best, Kate, if you want to answer those at the end of well, I'll ping you if there's some questions that need some immediate attention, but I think we've all used Zoom enough right now to manage our microphones and to put questions into the chat space. Okay, so I am going to now turn this over to Kate.
Thanks, Anna. Hello, everyone. Welcome to the iGuide VCO. I'm really excited to present this project that I've been working on for the last few months, and maybe do a little bit of demo and some Q&A if anyone is interested in learning more about the platform or about the notebooks. So if you do want to follow along with the demo that we'll do in maybe about 10 or 15 minutes, make sure that you have an IPUMS NHGIS account and an API code, you should automatically get an API key once you sign up for an account. You'll just have to look for that information within your account. And then I would recommend testing logging into the iGuide platform before we get started in the demo, just to make sure that you have everything set up. You'll need a CI login, so you can log in using institutional credentials into the iGuide platform. And I've put these two links into the chat, so you can potentially work on that, getting those set up while I'm introducing the projects. Thank you again, Diana and Minot, for the introduction. As Diana mentioned, I'm currently a postdoc at the University of Minnesota. I work with Dr. Eric Shook in the Department of Geography. And yes, thanks, Eric. Eric is also helping me out in the chat with the links. Thank you so much. I work with Eric Shook, Dr. Eric Shook at the University of Minnesota, Department of Geography, and I also work with iGuide and ISRD, which is the institution that hosts IPUMS. I guess before we get started, I have a couple quick questions. So I know that some people are here from kind of the iGuide side, and some people are here from IPUMS or heard about this webinar from IPUMS. Who in the chat, can you put a 1 in the chat if you came here from IPUMS or heard about this through IPUMS, and a 2 in the chat if you heard about it through iGuide? Okay, it's all okay. It's mostly IPUMS, a little bit from iGuide. Okay, thank you. That's really helpful. Next question. What are we gonna do? Put a 3 in the chat if you have used IPUMS NHGS before. And that'll be the only number. Okay, so most of you have. And last question, put a 4 in the chat if you've used the IPUMS IPUMS API for any reason. Okay, so we have some people who have used IPUMS API. Okay, great. So a lot of you will have some familiarity with these topics going into it. And I'll get a little bit more into how we can use the API and IPUMS NHGS data and spatial data workflows within R. Okay. So why did we decide, or why did we start working on this R Spatial project? So as many of you know, if you work with spatial data, often workflows involve a lot of different tools. Maybe you're working in GIS and code and some other platforms. Sometimes I can make workflows complicated or collaboration or reproducibility difficult. So one of the goals of this project for me was to kind of create a series of notebooks that can help you create workflows that are easy to reproduce and integrate a lot of different steps, including automated data acquisition through API from multiple sources, integrating or doing data processing and integrating those all within the same coding environment. So this can help streamline your processes and make workflows potentially more collaborative and reproducible. So a few goals of the project. First of all, to showcase in many ways how IPUMS data, one sec, I'll answer the question in a minute. Showcase how IPUMS data, especially the spatial NHGIS data, can be used in workflows in R and easily used, especially if you're leveraging the IPUMS NHGIS API. Yes, I can share them again. Second, one of the goals of the project was to bring a social data science and data analysis, or social data research and data analysis for the social sciences to the iGuide project and platform. And I'll talk a little bit more about the iGuide platform once we start working in the demos. But essentially, this is a platform for integrated spatial data analysis that combines both code and data sources and other parts of analyses in the same platform. And I also wanted to provide sort of a source of code and platform for learning about different spatial data sources and different spatial analysis workflows and tools within R. And hopefully this could be a space where you can download my code and modify it for your own workflows. Okay, so I'm going to take a quick pause and have another couple questions. Okay, sounds like my audio is okay. I'm not okay. Is anyone getting a 500 internal server error when they are trying to log into the iGuide platform? Oh, a couple people are. Okay. Yes, I can give a brief overview of iGuide. Okay, a lot of people getting that error. Do we happen to have any iGuide
Kate,
platform?
I'm gonna check with the people on the CI
Yeah, thank you.
team
Thank you
about
so much,
any
Diana.
issues with the platform.
Okay, so a lot of people are having login issues with iGuide. Um, someone looks like someone switched to Google Auth and that works.
Maybe post the link separately.
I'll post a link to log into the iGuide platform again. It should the landing page that's you start with should have options to do either the Google or the institutional login. Yeah.
And Kate, did you want people to be going to the platform or to the Jupyter Hub itself?
I was directing them initially to the platform just to make sure that they kind of go through the login process since
Right.
I've
Okay.
that
Just
before.
yeah, another note for the group who are trying to log into things. Given the size of this group, it's not going to be possible to troubleshoot every person's login issues other than broad scale ones that we may have. So it really might be better to watch along as Kate demos things, and you'll have all the information you need to troubleshoot your login at a later time. This isn't really meant to be a really large scale, everybody goes along at the same time.
Thank you, Diana. That's a good reminder, very helpful. Yeah, so I do have a link. Yes, even if you don't get iGuide access, you can access them. I have links on my personal website, and you can work on troubleshooting iGuide access login from there. Um, yeah, and then yeah, Eric has also shared a link to all of the notebooks available on the iGuide platform. So that's another place to access them. Right now, they're all set up to view within the iGuide platform, but I can also send out an email with some direct links if people want to specifically download the code. They are all just on my GitHub. But for the time being, yeah, if you're having trouble with the login, I'm very sorry, but we will be recording. We are recording this, and we will put it up. You will be able to walk through later. And I'm just going to go ahead with the demo. All right. Thank you. Yeah, it does look great on the website. Okay. So, oops. Yeah. So again, back to goals of the project, we also I want to sort of provide a source of code for people to use, and they can modify this code to their own needs if they need to. So far, there are about 10 or 15 notebooks that are live from the links on my personal website, and up to 25, there's 25 notebooks that are live on the iGuide platform. I haven't fully moved all of them over to the links on my website yet. And I'll be hopefully modifying and updating those, and also potentially adding more notebooks in the future. So if you're interested in this project, please feel free to follow along by signing up for my mailing list for the notebook, which is on that website that Eric just shared. Thank you so much, Eric, for keeping me up to date with the website or with the notebooks. Right, kind of at the end of the introduction section, there's a sign up for mailing list area. Okay. So moving on, as I mentioned, and as potentially you've seen on my website and on the iGuide website, the project right now is kind of structured as a series of code notebooks outlined kind of in a progressive chapter structure, kind of in a book format, and hosted on the iGuide platform. They're designed to be worked through, so more or less kind of in order from chapter to chapter. Some of the chapters have prereqs for previous chapters and kind of have a workflow from one chapter to the other. And that information is included in the notebooks with clear outlining of what the prereqs are and what you should do to be able to work through the particular notebook. These notebooks focus on IPUMS data sources, not just NHGIS, but the other tabular data sources that are hosted in IPUMS, including IPUMS USA, IPUMS International, and others. And but also includes a lot of data sources from other open source spatial and environmental data, such as Natural Earth, EPA Air Quality Monitoring System, OSM, and other sources, and I'll be hopefully adding more as I go along. My goal was to also have these notebooks be a place to consolidate information on a lot of nice open source data sources for social and spatial analyses, especially those that you can access via API, like with the IPUMS API, so that you can kind of work those seamlessly into any kind of a reproducible workflow in R. And as I mentioned at the beginning, the notebooks take heavy advantage of using the IPUMS API with the IPUMS R package. So that is a very a strong pillar of this notebook series is the IPUMS API. Okay, so now I'll go into the live code demonstration. I know a lot of you have been having issues logging in, so I'm very sorry about that, but we'll just go through and kind of view along instead of code along. As Eric has also put this in the chat a couple of times, but if you want to take a look at all the notebooks, the list of the notebooks, you can take a look at my GitHub page, Barbara Musser at github.io/rspatial to see a link or a list of all the links. Okay. I'm going to switch over to another window. All right, so I'm going to skip over this initial chapter. If you are new to the IPUMS API, I suggest walking through this when you have a moment. This also introduces a lot of the other data sets that I think are interesting or included in this chapters, one place or another. We're going to skip directly to the IPUMS NHGIS data extraction using IPUMSer, and that's IPUMSer is the R package that includes access to IPUMS using the API. Yes, Eric, thank you so much. I'm so glad you're here. All right, so what I did was from this link on my website, I went directly to the landing page for this particular notebook on the iGuide platform. So you should be able to see this even if you don't log into the platform. This has a preview of the notebook and this button here that directly opens the notebook in the iGuide platform. I want to give a shout out to the IPUMS team. A lot of the information that was the foundation for these notebooks is based on an article, Introduction to IPUMS API for R users, that I found extremely helpful. So just wanting to give a little bit of kudos there. I'm not going to go through all of this background information. This kind of gives an overview of what's in the IPUMS NHGIS data repository, and kind of reminds you that you should have walked through a couple of prereqs, including setting up your IPUMS API key, but we'll just move along through that. So these notebooks are designed to hopefully walk you through pretty clearly all the steps so that in the notebook, so that even if you are relatively new to R, you have an understanding of what's going on, including what packages we're using and where all the commands are coming from. But I'm going to skip through some of the kind of intro to R, more basic R coding elements and go right into the meat of this notebook. So we'll install all of our, or load all of our relevant packages. And here I'm going to input my API key, which I won't worry too much about you copying since it's pretty long. So now I have my API key set in the environment. I'm ready to go. The first thing I'm going to do is I'm going to work through in this notebook the process of setting up an NHJS, a data abstraction. There's multiple steps to the process. And I know a lot of you have worked with the IPUMS API before, so this might be review. But for those of you who are relatively new to it, I want to kind of focus on this first. And if we have time, we'll go into a little bit more detail with some of the later notebooks, but this will at least give you an idea of what these notebooks look like. So the first thing we'll do is get the metadata information for both the available time series tables. So those are that's the tabular data, non-spatial data component of the NHJS data repository, and then we'll go through the metadata of the available shapefiles. So these two processes, we're going to look through everything that's available and choose what time series tables and what shapefiles we want for a particular analysis. And then we'll set up the data abstraction and send that to the IPUMS API to call it. Thank you. I should do something like that. I'm not too worried about you stealing my IPUMS API. Maybe I should be.
Kate, I'm gonna just interrupt you for a second. Some people have asked whether you can just increase your browser font size for a moment.
Oh,
And anyone who can't see Kate's other screen, Kate is the one broadcasting. She's changing. I think she is on full screen right now, as far as I can tell. And yes, we're able to see the screen that she's sharing, which currently is showing the Jupyter notebook that she had set up for this particular process.
yeah, so I don't think I can. I think I know what you're doing. I don't think I can push this to full screen in this. This is about as good as I can do, but hopefully it's a little easier to read. Zoomed in a little bit. That's great.
Okay,
Thank
thanks,
you.
Kate.
Okay, good call. Thank you. All right, so we set our IPUMS API key. The next thing we'll do is when we look at our time series metadata and our shapefile metadata. So we'll start by getting all of the NHGS time series data from the IPUMS API. Yeah. Oh, this is actually, I'm going to take a quick aside to answer this question. So someone mentioned interesting to see in Jupyter Notebook rather than RStudio. Yes, so if you are an R user like I am, you're probably very used to using the R Studio platform for doing your R code. And I will admit that that is also more native for me. But I wanted to create these notebooks within the iGuide platform, which uses Jupyter Notebooks rather than RStudio. So the writing these in Jupyter Notebooks allows me to host them on the iGuide platform and do this kind of very easy way of sharing the code. But yes, it works exactly the same. It's R within Jupyter Notebooks, so you can do exactly the same things as you would do in any other R platform, but just within Jupyter Notebooks. Okay, so we're going to use this command. Yeah, it's easier to document. Use this command get metadata NHGIS to get all the time series table information. This extra step, I'm just telling R to print the first 10 lines, as well as store it to this metadata desk object I'm creating. So running this. All right, so we have returned all of this information. These are the first 10 lines of the metadata for the time series table. We can see that there's 389 available time series tables. And each of them has a name, that's the reference code, full description. This is some information on geographic integration. I'll talk integration, which I'll talk about in a little bit. And then we have actually 4 variables. Well, actually, we'll ignore the sequence level. 3 variables, time series, years, and this one that's actually hidden from our view because it's kind of truncating the view, geography levels. And these are all represented by these tibble structures rather than information. And what this means is that within this cell of the data table, there's actually another table, another tibble. Tibble you can think of as similar to a data frame if you're more used to working with those, but it has some extra structure, capability, and metadata storage. So what this is showing us is that in each of these cells, there's actually an entire another table. So that means, for example, this particular time series table, A00, has an additional list of available years, available time series, and available geography levels. So there's a lot of data here, not even just these 389 tables, but a lot of other options for the tables. So, and really high level of information that we have available to us. So what we're going to do, because it would be overwhelming, in my opinion, to sift through the hundreds and hundreds of potential tables, is filter the metadata by particular criteria. So what I'm going to do here is I'm going to take the metadata dats object that I stored all the metadata to, pass this filter command. So I'm going to filter using just the phrase total population in the description, and then select from that the subset that's just name and description and show that as a data frame. This is a little complicated, but all I'm doing is saying, take that object of all the metadata, show me the ones that are just about total population, and then show me a list of the names and descriptions so I can easily see it. When I run that, we see that there's 4 data tables that are about total population. That's A00, AV0, B78, and CL8. I'm going to take a pause here because I see that there's a couple of questions. Let me just make sure. Yes, slides will be available. Which cell did you have the cell not execute? Oh, actually, Casey, that's probably because you didn't, I'm guessing because you didn't add your API key. So if you ran that API key cell, you'll need to paste your API key into the text box and then press enter before Jupyter allows you to progress. So it's kind of like waiting for you. Let me know if that makes sense. Ashley, yeah, theoretically, yeah, you would want to, you don't want to import the notebook because it has all this extra markdown. But for each of my notebooks, and this give you a preview of the very bottom, I have this quick code section that is just the Python, or not R, it's just the R code. So if you want to use just that. Oh, and Jen adds an important point. I totally forgot. Yeah, ArcGIS uses Python, not R. So even though it's in Jupyter Notebooks, the code is in R, so you wouldn't be able to import it into Python, into ArcGIS. But thank you for your question. Okay. And thank you other people who are answering the questions for me in the chat. Is there a README with different clouds available in your population? Jessica, there are some resources online, which I outline if you kind of get into the text here. There's a list of the, yeah, so you can take a look at the NHGIS data finder if you're familiar with that for using the standard, kind of the standard method for doing extractions. There's also an overview of the NHGS data sets and the overview of the list of time series tables that are available on the NHGS website, and those are linked in the text. So if you go back through and kind of spend some time reading the text, there's a lot of information there. So hopefully that might be helpful. Yes, you can copy this R code into RStudio or any other R environment if you want to. You'd have to exclude the markdown, but yeah. I'm personally not super familiar with ArcGIS. I am not great at answering your ArcGIS questions, but if you can't find the function get IPUMS API, make sure that you run the cell where you load the library. Yeah. You know, you guys are doing absolutely fantastic answers and questions. Thank you so much. This is a great crowd. I think we're having some technical difficulties getting on the iGuide platform. So if you're following along,
Yeah, we've got the platform didn't
I feel
the cyber infrastructure team didn't know that this cyber size group of 200 plus people were all going to be using the platform at this exact moment. So it wasn't optimized for this moment. If any of you are using the platform at the same time right now, just for the sake of Kate's presentation, we're working on getting some more nodes. But if you could just let Kate get through this presentation and we'll follow up as needed for anyone who needs some additional help when you do run things on your own.
I'm gonna cheat a little bit, and since we're having a little bit of overload for the iGuide platform, I'm gonna just run this on my own machine. This is just my local copy of the exact same notebook, just so we can keep working through this demo. Yeah, great performance test, yeah. Okay, so we've got our metadata table. We did a little filter. We found the 4 tables that have total population. So now we're going to dig deeper into these 4 available tables. So we can use that get metadata NHGS command again with a specific table to take a look at the additional metadata for that. So I'm going to look deeper into CL8, and now we can see the information that was included in those columns that are represented by tables. So we have time series, which has a 1x3 tibble in it. The available years, which shows that we have these 4 years available. This is decennial census total population data. And we have a table of the available geographic years, or geographical years. So these are all the geographies that are relevant to this particular time series table. Okay, so yeah, this shows us additional information. So now we can go deeper and make more decisions about specifically what data we want from NHGS. This was only for one particular table, but I've created this little bit of code here that kind of creates a clean overview of all the tables that we identified through our initial filter. So here's these 4 tables, they're all about total population. Here's the available years and the available geographies. You can see that there's individual years as well as these 5-year ranges within the years, available years section, and those individual years correspond to the decennial census total population data. And these 5-year summary or 5-year ranges correspond to 5-year ACS population estimates. And you can read much more about the decennial census and the ACS. There's details in this notebook as well as links out if you are interested and if you're not familiar with these packages or these data sources. Okay, so now we're going to set up all of the parameters for a data extraction for the time series table. So we've created our selection. We've decided that we are going to use the CL8 data table. So I'm going to store that to an object just so we don't have to remember it. We could also just note it down or something. And then, so we'll store CL8 just to this selection dots object to use later. I'm going to do a quick review of what metadata we have, and then we're going to go from there. So we have these available years, these available counties. All right, so we've selected our data table. The next step is to take a look at the available shape files. So we have our table data, now we need the shape files, the spatial data. We'll do a similar step to take a look at the metadata. Whoops, I'm sorry. Scroll over that for a moment. Take a look at the metadata for the shapefiles. That's using that same get metadata NHGIS command, but for shapefiles again this time. I'm going to filter the available shapefiles by the year that we're interested and the geography level. So I kind of skipped over a little bit, but up here, before I went into looking at the metadata for the shapefiles, made a selection about what geographic level that we're going to use for this analysis. These are the available geographic levels for that CL8 table that we decided we're going to use. And for this exercise, I'm just going to use the county level. So I'm going to store that as well as county. And because this particular table has a geographic that's standardized to 2010, which means the geographies are standardized to the 2010 versions of the geographies. Some of these geographies change over time. For example, census tracts change every time the decennial census is conducted. So these standardization versions of the geographies are really important if you want to be able to easily analyze across multiple time series. And those are one of the amazing products, the standardization that IPUMS supports. Okay. So I decided on county. I'm going to do this filter of the shapefile metadata to only the shapefiles that are to 2010 geographies and are relevant to this geographic level, which we've decided is county. I'm just going to print all of them. Oops, I forgot to slide this. Print all of them that are available. So we've got 5 potential shapefiles that we could use. 2 of them are actually county subdivisions, and this one is county centers of population. So I'm going to pick between these 2 for the shapefile selection for our extraction. One of them, this one, is the 2010 geographies based on the Tiger Line 2010 shapefiles. And this other one is 2010 geographies based on 2020 Tiger Line shapefiles, which I kind of outlined here. And for this one, since we're interested in 2010, based on 2010 Tiger Line file or 2010 geographies, I'm going to choose this first one. So the 2010 Tiger Line based on 2010 geographies based on 2010 Tiger Line. So I'm going to save that to another object. So that's just the reference code for the particular shapefile that we're interested in. And now we are ready to set up our data extraction using IPUMS API. As a reminder, before we get started with setting up the extraction, I have this list of exactly the things, the minimum number of things that we need to pass to the function to have a functional extraction. So we need a quick text description that can be anything. I'm just going to use this simple IGUIDE NHGS data extraction as an example. We need our time series tables. So that's going to include the name, which is the time series table code. So that's CL8 that we stored to that object, and the geographic level. So we decided that we wanted to use county as our geographic level. And then the list of the shapefiles using those shapefile codes or shapefile code. So down here, we're setting up our extraction definition with the define extract NHGIS commands. And I've got a description that I've just decided to use to differentiate this particular extraction. Set up my time series table using this test or TSD spec function to kind of specify the details of the time series table. And within that, I'm going to specify the name with that selection that we previously made, and then the geographic levels with this geography selection we previously made. And then finally specify the shape files with that shapefile selection that we just made up here. Yes. Eric, thank you so much. All right, so set up the definition of the extraction. And this hasn't pushed the extraction yet. It's just set up all the parameters. Gonna do a quick review of it by just taking a look at it. Everything looks good. That's the right shapefile. This is the table that we decided on, the county or the geography level we decided on. So everything is looking pretty good. So now we're ready to extract or submit the extraction to the API. So do that with the submit extract command using our definition. And these extra steps here are just going to, they're not necessary, but they're helpful if you want to get this kind of preview of how your IPUMS extract is working. So this will tell you with your extract, and this will give you kind of a status update when it's complete. And this last command here in this chunk is to download the extract once it has completed. So using this check is also really helpful if you want to have all this code in kind of a long chunk of code that you run all at once, since it will kind of halt your code until the extraction is totally complete and then continue. So if your extraction isn't complete when you run this, it will throw there. All right, so we've downloaded our extraction, saved it to this file path function. Is it possible to subset on a data source, e.g. the ACS is an instance? So like, for example, maybe you only want the state of California or something like that. Is that what you're thinking? Or you only want like a particular variable? The question answering for Christian, who asked, is it possible to subset on data source? How can I find all the tiger shape files? There is, so the original Tigerline shape files are actually from the census directly, but the IPUMS repository of shape files you can find in this list of GIS files here. Oops. And this will give you an overview of everything that's available in IPUMS NHGS data repository, this GIS files. You can also find the list through the select data tool on the website. This is going to show you an overview. Or ACS versus decennial census, i.e. the metadata table document. Does the metadata table document exist? The metadata table in the that is passed to you and that you can work with directly in R, I think doesn't have a lot of details about the actual source, but you can check out the overview of NHGS datasets and listed time series tables, all this information on the IPUMS website, and that will give you all the details. So for example, the CL8 table, this one, CL8, that we're using, it's showing me the sources of those 4 variables that are included. So that's the total population from these 4 censuses. And you can see there's detailed information on where all the variables come from in there. It's based on FIP codes. Oh yeah, thank you for the link to the tiger shape files. Yeah, so if you want to download the tiger shape files directly, they are available on the census website, but you can also programmatically download them through IPUMS. which is more amenable to your reproducible workflows. Okay, so submitted or extraction saved in this file path object. So there's two elements in the file. You have a table of data and a shapefile. So I'm going to store those two to the two components here. So this is the first part of the file path. And the second part of the file path using the read and HTS becomes SF functions. So now we can take a look at what our data looks like that we downloaded. So just taking a look at the DAT component of our download, so that's the tabular data. You can see that we've got 16 variables for 3,143 counties. Those are the counties in the United States. And if we take a look at the first few lines of the data, we can see everything that's included, and this is just the tabular data. So we've got all these GIS related variables. So GIS join will be used to join this data to our shapefile. We have the year of the geography, and we know that we're using this 2010 standardized geographies, and then some information on state, the county, and state and county FIPS codes. And then we have these multiple population variables. Since we know we have population variables from the 1990, 2000, 2010, 2020 censuses, these are those four variables here, 2000, 2010, 2020. And then these other two are the lower and upper confidence intervals for the 1990, 2000, and 2010 populations, which are technically estimates. So there's kind of like a range of the upper and lower kind of error range. But if you're just interested in using a single population value, you use that these four variables, 1990, 2000, 2010, and 2020. This gives an overview again of all the variables in our data. So now let's take a look at the shapefile. So that's the other file that was downloaded in our extraction. We've got 21 variables for 3,221 counties, so a few more counties than the data, which is okay. And the columns that are included in this data, another bunch of different geography related variables. The one that we're interested in is this GIS join column, which we're going to use to match with the GIS join column in the tabular data. So both the tabular data and the shapefile have this GIS join column, which uses the match. I don't know why, but I didn't add a quick look at the data, but you can look at spatial or simple features data, which is a format for storing spatial data in R, in the same way you look at tabular data. So I'm just taking a look at the first few lines of the shapefile, and you can see information on all of the characteristics and also the special column, geometry column, which has all the information for the actual geographies for each of the census or the counties represented in this data file. So this is a multi-polygon, and these are, it's cut off here, but it's all of the coordinates for the nodes of the each of the geographies that make up the counties. So this is all just geography data and some related geography variables. Okay, so last step, we're going to merge these two data sets. So we have DAT, which is the tabular data, and SHIP, which is the shapefile, stored as an SF object in R. That's that simple feature spatial object in R. Merge these two, and this is our key by GS join. That's the column that's in both the DAT and shape files. You can use the merge function, just the base function in R, and store it to a new object, that shape. We'll take a look at that, and we'll see that we have all of that information from the population file, so all the population variables, as well as all the geography variables from the shapefile and the geometry. So we have all this geometry available for us as well. So we'll be able to map this file, including if we want population data. Last thing we'll do now is we'll save it. For this particular exercise, before saving, I'm going to subset the data to just the state of California. This just makes it easier since there's a smaller file just to work with for an example. So save to just the state of California. I'm also going to remove a few columns that have very intensive data, which also makes it easier to save. And then we'll write the file as using this std. So that's going to be the end of this notebook. We have about 12 minutes. I'm going to quickly run through. I didn't put a link here, of course. I'm going to quickly run through spatial data exploration and oops, do it on my computer. The spatial data exploration pre-processing, which will be a little bit just starting to show you how we can work with this data that we directly downloaded from IPUMS and USGS within R. Again, I'm going to skip through some of the background. What I'm going to do is I'm going to read back in that same file that we just saved. So we saved this IPUMS and USGS example.shp, the shape file, at the end of this previous notebook right here. So I'll read this back in, take a look at the data, same stuff that we were just looking at, same columns. And this notebook has a few steps that are really useful in the pre-processing stages, especially particularly for working with spatial data. I'm going to skip taking a look at the structure, but we're going to look at the CRS using this stcrs command. All of these commands that we work with here that start with st, like the stread function that we use to read in the data, the stwrite function that we used to write it in the previous notebook, this stcrs commands, all come from this SF package, which is the package that supports simple features in R, which is a method for representing spatial data. And it's kind of the go-to package when you start working with spatial functions in R. Okay, so we'll pass our data file, which is the combined data and shape file. Take a look at the CRS, and this is going to give us all this detailed information on our coordinate reference system for this particular shape file. We're going to be using this USA contiguous Albers equal conic. We have information on the ESPG code right here, and alternate Esri ESPG code here, and additional information. So from that, we can get some of the base information of how this data is stored in terms of the CRS. We can also use the parameters function. So this is, parameter from the set stcrs function to get extra detail on some of that. We can do a quick plot of the data using this stgeometry command. If we pass the SF feature to the stgeometry function, and then pass that to the plot function, the base plot function in R, we'll get a quick and easy map of our raw geometry. So that's just the geometry, not including any of the attribute information. We can also make a more fun plot with ggplot2. So I'm going to still do just the raw geometry, but I'm going to do it in ggplot setup. So the way ggplot works is you first set up a ggplot with the ggplot commands, specifying what data you want to use. So I want to use my dot file as the data. And then you use these plus operators to add other components to the plot. So adding geom_mapsep is going to tell the plot that I want to plot a spatial feature using the simple features in the simple features format. And so it's going to say, okay, we want this to be a map, essentially. And then we're going to add labels with the labs command. And we're going to just add this theme minimal. It's optional, but it's going to kind of change the theming of our map. And running that, you get this prettier version of our raw geometry. But we also have the attribute data that we included from our data extraction from NHGIS. We have that population data from the 4 decennial censuses. So what we can do is add within that GMSF component of the ggplot setup this aesthetic component. So it's going to say that we're going to fill the polygons using this variable within the shapefile. So remember we have the 1990, 2000, 2010, and 2020 decennial census total populations. So we're going to use the 2010 total population as the fill. I'm just going to add another element to the labels, the subtitle 2010 total population. And running that gives us this nice initial map of the relative population totals for the state of California. We can see that LA County has way more population than any of the other counties. You can change the color scheme by adding a color scheme parameter. My favorite color scheme in R is Viridis, and in QGIS is Viridis. So we're going to use the Viridis color scheme. These two plots or maps are using a continuous visual representation of the data, but I do have another one of my notebooks that does choropleth, that focuses on choropleth mapping for categorical data. So if you wanted to map categorical data with a choropleth map, or if you wanted to take your continuous data in R and chop it into categories and then map that as a choropleth, you can check out the choropleth mapping notebook. I also have, if you want an overview of managing tabular data in R, I have a notebook that's chapter 3.1 right before this one that focuses on data processing for tabular data. So for this notebook, we're focusing just on kind of the spatial component, but we do have all that population data attached to the shapefile as well. And we could do some pre-processing with that and focusing on the variables. But for this one, I'm focusing on the kind of geography. All right, so we did a little bit of overview. Then I'm going to take a couple of kind of essential pre-processing steps that you should know about if you're working in R. One is how to project the data. So we saw before with the stcrs command, we'll return the CRS information for our data. We can also use the st transform to transform to any other CRS. So here I'm taking my DAT file and transforming it to WGS84 using its APSG code and storing it to this new object, that pre-plunge. So I'll do that, and then I'll plot, and you can see that the data is reprojected, looking a little bit different. For comparison, here is the original data, and we projected it into WGS84. You can also use S3 transform with the CRS of another object rather than the APSG code. So for example, down here, I'm going to do an ST2 transform and take that reproj and project it back to the CRS of the original jet. So I'll just pass this ST-CRS DAT that's getting the CRS from the DAT file, pass it directly as the CRS. And now that DAT reproduces back to the original CRS. Jonathan, thank you so much. You're fact-checking me on my background on where the NHGS tiger line relationships are. Thank you. I'm glad you're here. Okay, and the last step for this data preprocessing or spatial data preprocessing notebook, I'm going to do a quick check on the validity of the geometries in my data file. This is a really important step if you want to work, if you have downstream analyses, as if you have invalid geometries in your data, it can affect analyses, can throw errors during analyses, or end up having your not visualizations be kind of incorrect or not what you're expecting. So we're going to use this st as valid function with that to check and see how many of the geometries within the depth file are invalid. And so I'm going to pass the results to this object. This is just a list of yes and no, basically, and then take a look and see how many are invalid with the sum command. And there's actually one invalid geometry here. So we're going to quickly fix it using the st make valid function by just passing that to st make valid. And if we run our valid check again, now we have 0 invalid geometry. So we're ready to go. At the end of this, I'm going to write my data again as a new version, and we can move this to more analyses in the future. So we're right at 1 o'clock. I know this was a quick overview. I know a lot of you already had experience with the IPUMS API, so hopefully this wasn't too much of a review. But what I want to stress here is the usefulness of using the IPUMS API and APIs for other data sources, which we didn't get into, but some of my other notebooks use APIs from the EPA, API from Natural Earth, and others to bring this data and bring multiple data sources programmatically in, and then working with them. So all of this that we've done here, this is with data that we just extracted directly from NHGS. We could really easily go back to that original notebook, change one parameter. For example, maybe we wanted to do one of the different tables, not CL8. We could really easily change that, run this whole thing again, and you have a totally updated analysis based on whatever new parameters you have. So very powerful, and I hope this was helpful. And please take a look at my website. And if you want updates on when I finish other notebooks, please sign up for my email list. And this will be recorded and put on the iGuide website. And thank you so much. I'm so glad.
Thank you, Kate.
Yeah.
Thank you, Kate. Yes, the recording of this, I'm going to quickly put the link to our VCO page here as soon as I pull up my browser, which is not loading right now. Hey, anyone from iGuide, how quickly can you put the VCO link up there? Here we go. iGuide, i-guide/io.io/VCO. Let's see if that works. Nope, that's not it. Here we go. Here's the right one. So iGuide, we didn't get a chance to really talk about iGuide more. I encourage you to take a look at our website and see a little bit more about what iGuide has to offer. Our VCOs, we hope to have on a pretty regular basis, like once a week or once every 2 weeks. So thank you for coming to this one, and learn more about iGuide, and keep in touch and pay attention to all of these resources on our platform. There are going to be many more added soon. We're in the middle of a spatial AI challenge, and all of the deliverables and resources from that activity will also be up on the platform soon. Kate, thank you so much for sharing the work that you have here.
Thank you. Thanks, everyone.
Thank you, Kate.
Thank
Bye-bye.
you, Kate. Bye.
Yes, we'll be sending out links. Thank you.
Yep,
Yep.
links will go out. Thank you.